broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome into the program. I hope that you had a great week and you are ready for, well, Ralph Bond. I know he's really hard to prepare for. You really got to, get your coffee, got to get things going. But don't worry, it's going to be a lot of fun. And we are ready for our science and tech trends correspondent to bring us stories that, maybe you had missed, maybe you just weren't paying attention to. What can I say? The headlines every week are so outrageous that sometimes you need to take a step back and, talk about megawatt batteries, just something to really take the edge off. So, ladies and gentlemen, computeramerica.com. That's where we'll find everything, including the show notes, past shows, future shows, articles, podcast distributions, social media links, all that and more. Computeramerica.com. Check that out. And while you're there, of course, the show notes are super important because Ralph puts together the show notes, does a great job. And, if you are busy, if you have your hands tied, don't worry. Computer America will have everything that you can go back and really fact check and check his sources. He does a good job of that, because he's a great aggregator. So with that being said, let's go ahead and just bring Ralph on and, have fun with it. It's a nice Friday. Everyone, let's go ahead and get started. So Ralph, welcome back onto Computer America. How you been?
I'm doing great. It's always great to be here. And folks, if you're brand new to the show, let's lay out what Ben and I do every Friday. What we do is we highlight 4 recent articles that show us key trends and developments in artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, space research, physics, you name it, everything is open to us to explore if it has anything to do with science and technology trends and where we're headed in the future. And most important of all, as Ben alluded to, we're going to give you an oasis of positive news, thanks to the world of science and technology.
Absolutely. And for those out there who are watching the video, we appreciate that. And you can, of course, follow along. But if you want to, by the time that you hear this, the show notes will be published. So you can check that out on computeramerica.com. And for those who are watching, you can see story number 1 is going to be about what I mentioned before. Batteries, not just batteries, but big batteries. Like if they were, C cells or AA's, these would be like 85 megawatt Bs, like just giant batteries. But, and really what it provides for, or like what we can do with it, I'm sure the article gets into that, is really amazing. So let's go ahead and start with story number 1.
Yes, story number 1 comes from SingularityHub.com. And the headline here, I couldn't resist this: world's biggest battery will provide 85 megawatts to New England grid. And we're going to learn about a battery technology I hadn't heard of before. This is another reason why I love this article. So here we go. Let's get into the story. So far, most grid storage, so, electric grids, folks, that's where all this energy is stored for a large distribution into communities and business centers and so on. Okay, so that's what a grid is. But so far, most grid storage facilities rely on lithium-ion batteries. We're all familiar with that. The same technology found in cell phones and electric vehicles and all over the place, right? But, and I think most of us know this, these batteries are relatively expensive and not particularly long-lived. They're also prone to setting fire. We've heard those horror stories, which makes them less than ideal for grid storage facility projects. Well, with that in mind, Massachusetts-based company called Form Energy is betting that its novel iron-air chemistry, which is specifically designed for long-term energy storage, could be the answer for large-scale grid storage batteries. Wait a minute. iron air chemistry, iron air batteries. Never heard of this before. That's why I love this article. And by the way, this company is set to receive $147 million to build a facility in Maine capable of storing enough energy to provide 85 megawatts of power for up to 100 hours. So there's a side note in the show notes about iron air batteries. Iron air batteries are an innovative type of energy storage technology that utilizes iron as the anode and atmospheric oxygen as the cathode. What? Wow. And in the show notes, Ben mentioned that. Come out to computeramerica.com, get the show notes for today's show if you want to learn more, because I have a tutorial and references and so forth about what is this all about? How does iron air batteries work, or how do they work? It's all outlined here, and there's references, and you can get more information.
Yeah, it's really cool because you kind of alluded to it earlier with lithium-ion batteries. Like, that's why you can't have your cell phone or laptop packed away in your stowage bag, on airplanes, is because when they're introduced to air, things tend to explode. It's really, really bad. And obviously when you're talking about, you can see the picture here, Ralph, an explosion like that would probably cause a lot of damage. But the fact that it's iron air, I've never heard of that. So, thank you for, something that doesn't just is in, like non-reactive to the air, but is actually useful, to be reactive to the air, is very, very different. So yeah, I'm sorry, please go ahead.
No, that's cool. And the CEO and co-founder of Form Energy said in a press release, quote, located at the site of a former paper mill in rural Maine, this iron air battery system will have the most energy capacity of any battery system announced yet in the world. Wow. And thank goodness, hey, it's happening in the United States. You got to love that. The project, which is due to be completed by 2028, is part of a broader package of funding from the bipartisan infrastructure law to upgrade the power grid in the northeast of the United States. Now, here's a little bit, though, on how this technology works. The key ingredients of the company's battery cells are iron and water. Iron and water, not exactly rare stuff here. And they rely on the same process that causes rust to charge and discharge. Ben, this is so freaky weird. It blows my mind. Energy is stored in the battery by converting iron oxide into pure iron and emitting the oxygen into the atmosphere. To release that energy, the battery absorbs oxygen from the ambient air to turn the iron back into iron oxide. Okay, but reality check. This approach can't get anywhere close to the energy density of lithium-ion batteries, a crucial consideration when packing batteries into small devices or trying to boost the range of cars and vehicles and trucks and so forth. That's a qualifier here. But here's why this is still of interest. But when building large-scale storage systems, and the image that's in the article shows the planned facility, it covers acres and acres and acres of land. But when building large-scale storage systems, energy density is much less of a concern than cost, a metric on which iron air batteries win hands down. Wow. And I would think safety, too, relative to that business of fire and explosions and all that kind of stuff. Fun technology.
It really is, and I know that they focus on the cost, and you can see from the image here that they're going to generate electricity using solar panels, and I'm sure wind turbines there to the side, lots of different ways to kind of generate the electricity that will then feed the batteries. But even so, safety I think really does have to be a key part of it, because a few times we have seen lithium-ion battery facilities kind of go up in fire, and it gets out of control very quickly and very, very dangerous. And I think this would have a much less chance of, the whole thing going up in flames. So there you go. A very cool story, new technology I hadn't heard of, but makes me happy that I skipped chemistry in high school, because it's hard to understand really any of that. It's at least for me, this early in the morning. So everyone, story number 1, if you want to check out links, go ahead. Pictures are cool. Story number 2. Let's go ahead and talk about this. origami, generally not the highest form of technology. It's a practice that's been going back, a long, long time. Very meditative thing. But I'm sure that the scientists who did this next story found it anything but meditative, and I'm sure a lot of hard work was put into this. This is very different, and honestly, Ralph, like, you actually turned me on to the series on Netflix. It was like the time machine thing. It was about the building of the James Webb Telescope on Netflix.
Yes.
Very, very cool, and like, it instantly reminded me of that because I watched that just last night, and they were talking about how they had to essentially fold up the James Webb Telescope and then reassemble it mechanically in space. So, very similar, but this is obviously something a little bit different. So go ahead.
Yeah, spectacular challenge in the James Webb Telescope. But this story comes from space.com. Headline: Origami-inspired transformer robots could help build habitats in space. Subhead: these configurable bots could launch flat and then be assembled in space. Now, I've got a link to the article, of course, but I have other supplemental links to learn more about this. And there's a great video, too. Really cool video the team put out that I encourage you to check out if you're listening to us a podcast. Come out to computeramerica.com, get the show notes, check out that link. So here we go. A newly designed transformer robot with the ability to change shape could one day be used to build habitats in space. Engineers from North Carolina State University have created a plastic cubed structure that can transform into more than 1,000 configurations using only 3 active motors. In theory, need to clear my throat, excuse me. In theory, their design, which was largely inspired by paper folding art of origami, offers a more efficient way to send assembly structures into space, where the robot could then transform to serve various purposes, including carrying a load. Really a hoot. And then check out that video. Fire that thing up because it's just amazing.
Yeah, so it really is. And let me. Oh wait, what the? YouTube is blocked. What? One second. I don't know why YouTube would be blocked on this computer. But yeah, no. So my immediate reaction of the James Webb Telescope makes perfect sense because it is about assembling something in space and it is for space. Kind of research. So yeah. Okay, so real quick, and let's do this. This is this. So if you're watching the video portion, you can see me struggle to kind of do this. We'll have this playing in the background, but yeah, you can see the gentleman there putting it all together. So
it's so great. It's fascinating and it's so clever. So the team's transformer bots consist of 36 3D printed hollow plastic cubes assembled with rotating hinges. And the video does such a great job of explaining this. You really must see pictures and this video, folks, to understand what we're talking about. Some of the hinges are fixed with metal pins, while others are activated wirelessly with a motor. The researchers were able to transform the robotic structures into various shapes, ranging from tunnels and bridges to multi-story architectures. In the process of changing shape, the transformer bots are able to move forward, backward, and sideways. They can move. The bots can transform relatively quickly from flat or fully open to a box-like larger cube or fully closed structure. Oh boy. They can also carry a load, about 3 times their own weight, and travel up an inclined surface. I mean, the range of possibilities here. And the video right now is showing the cardboard mock-up the researchers put together, and they're playing around with out in an open field. It's just so much fun. That video is great. Co-first author. Yeah, go ahead.
And it's if this doesn't work out for space, they have a pretty good idea for a new line of toys. It's fun to look at. It's very fun to look at.
It is. You're right about toys. Yes, I think my grandkids would love this kind of thing. So to wrap this up, the co-first author of the study and a North Carolina State postdoctoral researcher noted, quote, "We think these can be used as deployable, configurable space robots and habitats. It's modular, so you can send it to space flat and assemble it as a shelter or as a habitat, and then disassemble it." So the versatility of this is just off the charts. A great robotics breakthrough.
For sure, for sure. So there you go. It's again fun to look at, but and kind of not really silly with the cardboard boxes. Obviously, they have to get kind of the idea with the design down. But yeah, it for space where weight is a premium, size is definitely a premium, all that kind of thing.
Yeah.
This really does. And again, my whole thing about the James Webb Telescope at the very beginning. If they were able to fold that thing even tighter, I'm sure that they would have. So research like this could, maybe see itself on a lot more future missions. So very, very cool. Story number 2. Story number 3. Let's go ahead and talk about how photonic chips, which sound tasty, but I'm sure are anything but. This is a technology that I'm not the most familiar with. So hopefully Ralph has his side notes handy for everyone out there. And let's go ahead and talk about story number 3.
Yes, this comes from techexplorer.com. Headline: New engineering approach could lead to widespread adoption of photonic chips in consumer electronics. And we'll try to explain this. I'm going to warn you up front. This is a very, very geeky topic and story and so forth. I don't claim to understand it fully. I have a lot of links if you want to learn more in the show notes. But first, let's do a kind of a tutorial refresh on photonic chips. All right. Photonic chips, also known as photonic integrated circuits, use light, photons, instead of electricity, electrons, to process and transmit data. So it's pretty simple. Instead of electricity to transmit data like our traditional smartphones, laptops, desktops, big computer centers, you name it, they're using light to transmit data. That's the fundamental difference. In the show notes, I have more information and links to learn more, but briefly, photonic chips offer several significant advantages over traditional electronic chips. High speed, high bandwidth, low energy consumption, miniaturization, low thermal effects, large integration capacity. Wow. And these advantages make photonic chips particularly useful in fields such as data communications, sensing, biomedical applications, and even in the development of faster and more energy efficient artificial intelligence programs.
Much needed.
I got a whole bunch of tutorial links in the show notes if you want to learn more. And now for the news outlined in the article, which opens with a bit of a tutorial as well. It opens with photonic chips, also known as photonics integrated circuits, as we mentioned before, can now be found in telecommunications devices, autonomous vehicles, biosensors, and consumer devices such as mobile phones. But here's the problem. A key shortfall of current photonic chips is the lack of an on-chip light source. So if you're going to do computing with light, well, wait a minute, and you're going to have a photonic light-based chip to do this, well, you need the light source. So right now, the problem is a lack of an on-chip light source. Currently, these chips require an external light source, preventing the further miniaturization of the chips and the devices they enable. There's the problem, okay? Now, enter one way of working with this. Nanowire lasers, that's geeky, are an excellent candidate for these light sources, but high-quality nanowires with smooth sidewalls, controlled dimensions, and precise crystal composition that operate at room temperature have been difficult to fabricate at scale to date.
I'm not like... And this is way above my pay grade, but it sounds a lot like the same limitations of carbon nanfiber. Graphite. I'm sorry, graphite. Or I should say graphene. Is actually what I meant, not graphite. Graphite's everywhere. Right. Graphene. It seems to have a lot of the same difficulties of fabrication that graphene does. So. Yeah, and we for 10, 15 years we haven't been able to figure that out. But hey, maybe this one.
Yeah. And in the show notes, because this is so geeky, folks, we're not going to go through all of this data that we have, but in the show notes you can learn more. But quickly, nanowire lasers are a type of laser that operates at the nanoscale. Tiny, offering unique advantages for various applications. And again, you can go into the show notes and learn more about that and follow up on related articles to help you too. But with all of that said, Here's the news. Researchers from Australia's TMOS, TMOS, which is the ARC Center of Excellence for Transformative Meta-Optical Systems, that's a mouthful, have developed a new alternative to nanowire lasers, or a new alternative engineering approach to nanowire lasers, to on-chip light sources that could lead to widespread adoption of photonic chips in consumer electronics. So they've come up with a breakthrough that could make it possible to make these practical for consumer electronics. This could be potentially just earth-shaking. In research published September the 4th, very recently, in an outlet called Light, Science and Applications, the team from the Australian National University and their collaborators at Northwestern Polytechnical University outline a method for growing high-quality, multi-quantum, nanowires made from semiconductor materials, indium gallium arsenide and indium phosphide. Okay, folks, this is super, super geeky stuff. Just to kind of clear things up, simple thing is we're looking at a breakthrough in technology that could make photonic light-based computing practical for consumer electronics. That's the key takeaway here. All the rest of this is a lot of very geeky stuff. I've got optional side notes you can check out. And what I'm about to read, though, is supremely geeky, but it's kind of fun. The ARC Center of Excellence for Transformative Meta-Optical Systems team of researchers and their collaborators have developed an innovative multi-step facet engineering approach for nanowire laser growth, using selective area epitaxy by metal organic chemical vapor disposition technique. Okay.
About halfway through, my brain just
shut up.
Yeah,
Yes.
just popped. It was yeah. No. But it's like, even okay, ladies and gentlemen, go read the sentence. It's long, but still, what they're saying is, they've developed it, and it's cool. It's good, I guess.
The bit about on-chip light source for photonics is the key takeaway here. And you can go into the show notes and get some quotes from the one of the authors of the study. And if you're scratching your head, so am I. But here's the bottom line. This research breakthrough to create viable on-chip light sources for photonic chips could lead to widespread adoption of photonic chips in consumer electronics. That's the takeaway. Drum roll, please. Ta-da!
that is like the one sound effect I actually don't have anymore. I don't have. I need to get a drum roll. I even have needle scratch, but I don't even have a drum roll. So, but still, very, very cool story. And hey, it's I've heard a lot, Ralph, actually, about new processors using using light instead, and it makes sense in so many controlled situations. Don't think it's going to make it to your home PC, your home desktop, but it might make it to data centers, for instance, would have huge applications for this. So even if you may not see it in your hand, you will see big implications behind the scenes. So very, very cool story number 3. Story number 4. We'll just go ahead and jump into this. And yeah, it's it reminds me, there's a webcomic called, I think it's XKCD or something like that. XKCD, great webcomic. And it's about, they have one, Ralph, that is about cancer research and cancer cells. And they want to put a big qualifier. It's like, if you ever if you ever hear a headline about something destroying cancer cells or something destroying, whatever kind of cell, remember, so does a handgun. It doesn't really matter because it's so easy to destroy a cell, but it does matter about the application and the use case. So many things can destroy cells. It's just, how do we destroy them well, effectively, efficiently, and hopefully non-invasively? Those are the key parts, not just that a cancer cell is getting destroyed. So story number 4 should hopefully, kind of answer a few of those other questions.
Absolutely. Your outline in the preface there you just did fits this story perfectly. This comes from sciencealert.com. Headline: Scientists destroy 99% of cancer cells in the lab using vibrating molecules. How could you possibly resist that?
Really
headline?
cool.
So interesting. So let's get into this. Scientists from Rice University, Texas A&M University, and the University of Texas have discovered a remarkable way to destroy cancer cells. That's the understatement of the century. Remarkable. Stimulating aminocyanine molecules with near infrared light cause them to vibrate in sync enough to break apart the membranes of cancer cells. Oh, wow. Vibration to kill cancer cells. Love it. Okay, so timeout. What are aminocyanine molecules? Aminocyanine molecules readily attach to the outside of cells because they are positively charged and latch onto the negative charge of the cell's phospholipid bilayer. When activated with light, the electrons inside the aminocyanine molecules create plasmons, which excite the entire molecule and cause it to vibrate. Again, folks, this is geeky stuff. I don't pretend to understand it all, but you kind of get the picture here. Aminocyanine molecules are already used in bioimaging as synthetic dyes. Commonly used in low doses to detect cancer, they stay stable in water and are very good at attaching themselves to the outside of cells. So we're talking about taking something they already knew about, aminocyanine molecules used for synthetic dyes and bioimaging, and saying, wait a minute, we can make these little turkeys vibrate and kill cancer cells. Love it. The research team from Rice University, Texas A&M University, and the University of Texas, again, this wonderful collaboration, said their approach is a marked improvement over another kind of cancer-killing molecular machine, as it were, previously developed called Feringa-type motors, which could also break the structures of problematic cells. Chemist James Tour from Rice University noted, quote, "It's a whole new generation of molecular machines that we call molecular jackhammers. They are more than 1 million times faster in their mechanical motion than the former Feringa-type motors, and they can be activated with near-infrared light rather than visible light. And the faster comment refers to the vibrations. So more than 1 million times faster than the current previous technology to try to do the same thing. Wow.
and can use near infrared light instead of visible light because, getting, I don't know. I feel like if you have to cut open someone and do this process by, shining a light on them is pretty invasive in itself. Even if you don't use a scalpel to cut the cancer out, you still got to get in there to show the visible light. So this is still, big improvement there. Very, very cool.
Yeah, absolutely right, Ben. In fact, it goes on, and to your point here, it says the use of near infrared light is important because it enables scientists to get deeper into the body. Cancer in bones, and there you go. Cancer in bones and organs could potentially be treated without needing surgery to get to the cancer growth, to your point, Ben. In tests on cultured lab-grown cancer cells, the molecular jackhammer, as they nicknamed it, method scored a 99% hit rate at destroying the cells. This approach was also tested on mice. Thank you, mice and rats, once again. Tested on mice with melanoma tumors, and half the animals became cancer-free. Wow.
Melanoma. I didn't think about that. Cancer that grows on the skin. That'd be a perfect application for something like this.
Wouldn't it? Isn't that something? And other applications too. I mean, this is profound breakthrough stuff, folks. So chemist Ciceron Alaya Orozco, I'm sorry to butcher that name, from Rice
University. He said that
University.
Perfectly, ladies and gentlemen. Don't let him fool you. That was perfect. Okay. Good job, Ralph.
Tried. From this fellow from Rice University, a chemist, said, quote, "This is the first time a molecular plasmon, Plasmon, is utilized in this way to excite the whole molecule and to actually produce mechanical action used to achieve a particular goal, in this case, tearing apart cancer cells' membranes." And in the show notes, I have a photo of this gentleman. Applause, applause, hooray, hooray. I love it.
Very, very cool research. And hey, in the field of cancer, it's, you really can't hope for much more than 99% hit rates. And then, of course, such great results as that. So Man, I don't know. It almost feels like naive how hopeful scientists were like in the 80s and 90s when they're like, we're going to get a handle on cancer. We're going to cure cancer.
Yeah.
There's so much research, so many different ways to kind of go at this.
Yes.
I'm not saying it's an impossible task. It's such a complex task, and they're still working so hard on it. So very, very cool.
Very cool.
New technologies. So there you go. Ladies and gentlemen, if you can keep it count in your head, that was story number 4. And of course, that means that, hey, that's about it for our show today. And I want to thank Ralph for joining us here and, really talking about all these stories. If you are following along, if you're watching the video portion, you can see, hey, but Ben, there's honorable mentions. Honorable mentions are stories that we just didn't have time for. We're not going to go in depth on them, but Ralph is going to at least read us the headlines, give us a bit of teaser, and you can go on out to Computer America and check them out yourself. So, Ralph, honorable mentions.
Yeah, here's 4 honorable mentions this week. This one comes from interestingengineering.com. Headline, water drop inspired wheel changes shape in real time to conquer any terrain. Ben, there's been a lot of research worldwide on alternative ways to make a wheel, reinventing the wheel, as it were. This is a great example, a lot of fun. The picture in the article is great. Next one comes from gadgetreview.com. Headline, 16 astounding flying cars that could revolutionize travel. It's a lot of fun, and the images alone are worth checking out. So check that one out. The next one is from CNN. Headline, hydrogen-powered skyscrapers set for Egypt's new capital. Wow. Recent show, we talked about a apartment complex in Korea that's hydrogen-powered base. Here we have a hydrogen-powered skyscraper in proposal set to be Egypt's new capital. Great story. Beautiful, beautiful images. Check it out.
Great trend for, of sustainability and eco-friendliness is hydrogen power. I'm beginning to catch on, Ralph.
Yeah. Boy, you and I have seen that trend a lot in the last several years. And here's today's last honorable mention. This comes from superinnovators.com, a fun website. Headline, world's first jet-powered humanoid robot. World's first jet-powered humanoid robot. The pictures and videos are a hoot. It's in the early stages of research right now, folks. It's not flying around right now, but check it out. It's kind of fun.
The pictures of this thing are... It's hellish. I don't know why they gave it that face. It's ladies and gentlemen, go check out the video, go check out the picture, see what I'm talking about. The pictures a little creepy is a good way to put it. It's almost like one of those kind of like baby dolls that you give to kids, and they have like the eyelids that kind of go open and shut as you kind of, I don't know, that's a weird one. But hey, it's okay to end on a weird one. Ladies and gentlemen, thank you so much for tuning in. The music means that we are done, and catch us here next Friday, every Friday, with Ralph to talk all about science and tech trends. It's always a lot of fun, and hopefully it was a good way to start the weekend. And ladies and gentlemen, I hope you do something fun and you catch us back here, same time, same place. Ralph, thank you for doing all this, and thank you, computeramerica.com. Catch you next time. Bye, everyone.